Hi everyone and welcome to today's session. Now what we're going to be having a look at today is two more tectonic plate margins. So we are going to have a look at a destructive plate margin and a conservative plate margin. Now all you're going to need for this session is a piece of paper and a pencil. If you've got some colouring pencils, you might want to use those as well just to make some of the diagrams a bit pretty. But other than that, that is all you need. Now before we get started, please can I ask you to turn your phone off, shut the door, and let's get going. Okay, so let's make a start. So our title for today's lesson is Why Do Tectonic Hazards Occur on Destructive and Conservative Plate Margins? So please can I ask you to write out the title. It's a question, so remember your question mark. And if you have a ruler, can you underline it and make it look really smart? Now, there's two key terms in this title that are going to be really important moving forward. So we've got destructive and conservative. Now, they are going to feature heavily in today's lesson, so almost might be worth highlighting them in your title. Okay, so this should look familiar if you did the last session where we looked at constructive plate margins. And the reason that I've put this in is I wanted us to recap on what we'd already learned. Now, last session, what we looked at was the fact that the majority of tectonic hazards occur on different tectonic plate boundaries. And the one that we specifically reviewed was a constructive margin. Now, the constructive margin on this diagram would be the Cocos plate moving away from the Nazca plate. But actually, there are two other types of tectonic boundary that we also need to know about. So could you have a really good look at the diagram? And I want you to look at the other two sets of arrows. And I want you in your mind to think about what those arrows signify. If the Cocos plate and the Nazca plate are moving apart, what is happening in the Cocos plate and the Caribbean plate, and the North American plate and the Pacific plate? Okay, so the Cocos plate and the Caribbean plate, we have the two arrows pointing towards each other. Now, if the arrows are pointing towards each other, what that means is the two plates are moving towards each other. Whereas when we look at the North American plate and the Pacific plate, those plates are moving past each other. So that is what we're going to have a good look at today. Destructive plate margins, conservative plate margins. Okay, so let's start by having a really good look at this diagram. Now, the diagram shows us what is happening on a destructive plate margin, and actually helps us to revisit something that we learned in one of the previous sessions about the two different types of crust. So I'm going to give you a few seconds just to have a look at that diagram, read the labels, look at the arrows, and let's see where you can get to in terms of figuring out what's happening. Okay, so what we essentially have is our oceanic crust, which, as you might remember, was denser, was 5 to 10 kilometers thick, and could be destroyed, and new crust could be created. And what we've got is that moving towards our continental crust, which is actually a lot thicker. So we had 30 to 50 kilometers. It was less dense. And as a result of that, when those two plates meet, the oceanic plate is subducted beneath the continental plate. It's forced below it. Remember, subducted was another word for sinking. Now, on a destructive plate margin, we get both earthquakes and volcanoes, which we can see in this diagram. So if you have a look at where the arrow says subduction zone, that is where we've got these two colossal plates colliding with one another. And what tends to happen is as the oceanic plate is subducted, forced below the continental plate, there is tension that builds up between the two different types of plate. When that tension is released, it's released in the form of an earthquake. The other thing that happens, and I'll show you with the cursor, is here we have got that oceanic plate being destroyed as it makes its way into the mantle. And what that creates is a whole load of magma, which then forces its way out onto the Earth's surface to create a volcano. Okay, so the task that I'm going to ask you to do that relates to a destructive plate margin is a really, really important one. Now, this comes up in exams a lot, so it is definitely worth taking some time over and really having a good think about. Now, often what they might ask is for you to draw an annotated diagram. So think back to what an annotation was. Good, so it's different to a label because an annotation is kind of a full explanation. And what they want you to do is to be able to draw a diagram and then to be able to add the detail to the diagram that explains what's happening, so that the examiner or whoever it is that's looking at your diagram can see that you understand the order with which things would occur and where they would occur when two tectonic plates meet. So, if we first of all have a look at the diagram that I've put on the screen for you, it's a fairly simple one. Yours doesn't even need to be as detailed as that. So long as you've got your continental plate moving towards your oceanic plate, the subduction taking place of that oceanic plate, an area where earthquakes could occur, and an area that shows that there are also volcanoes, you are good to go. I would keep this as simple as possible, a line drawing, okay? This isn't art, this is geography. Then the annotations that I would like you to add are the following. So the two plates are moving towards each other. Now, if you have a look at this diagram, part of that is missing. So there are the black arrows that show that the oceanic plate is moving towards the continental plate. But actually on this diagram, the continental plate doesn't show that it's moving towards the oceanic one. So if I was you, I would add that to my diagram. Okay, then we would have the oceanic plate is subducted below the continental plate. Now remember that really important geographical term, subducted. It means to sink. Then we've got pressure builds up between the plates, and when it is released, it causes an earthquake. Because again, we're linking to the fact that these margins create tectonic hazards. And then last but not least, the oceanic plate is destroyed and creates magma, which is forced out in volcanoes. So, pause the video now, take your time, add the annotations where you think they should go. What I do when I draw a diagram like this is I use an arrow that points directly to where I'm talking about. And then we'll go through and have a look at the answers. Okay, let's have a look. Did you get it? So you can see that on my diagram, I also added numbers to show the sequence with which this would happen. Now, the reason that I do that is just to make it really clear, like I said to you before, that if you're explaining a process, it's really important that you do it in the correct order. So, box number 1, the two plates are moving towards each other. So that's where I would have added my other arrow to show that the continental plate is moving towards the oceanic one. Then, 2, the oceanic plate is subducted below the continental plate. So I've labelled that, annotated that at the point where that is happening on the diagram. Then, pressure builds up between the plates, and when it is released, it causes an earthquake. Now, if you have a look on that diagram, that actually shows us the focus of the earthquake, so where the energy is actually released from. And you can see that the little squiggly red lines, that's what they signify, whichever. So that shows us that that's where an earthquake would take place. Then the last part of the diagram, the oceanic plate is destroyed and creates magma, which is forced out in the volcano. So I've added that directly to the part of my diagram that has the volcano. So what I would like you to do now is to go through your diagram and to be so strict on yourself. Are your arrows pointing to exactly what you're talking about? Have you spelt the key terms correctly? So things like oceanic, subducted, magma, those are key terms that we would need to spell correctly. And also, have you ordered your annotations so that they demonstrate the sequence? So if you need to redraft or to add some detail to your diagram, pause the video now, take your time. Okay, so this is the last of our 3 tectonic plate margins, and this one is called a conservative margin. So say that word after me, conservative. Good, you will have heard that word before. There is a political party in the UK that is called a conservative, the Conservatives. Now, at a conservative plate margin, it's actually different to a constructive and a destructive one because only earthquakes occur. So that's the first rule, okay, is that conservative plate margins are slightly different because only earthquakes occur there. Now, what you have is you have 2 plates and they are either moving past each other in different directions, or they could be moving in the same direction, but at different speeds. In our diagram that we've got on the screen, you can see that they are moving past each other in different directions. Now, what then happens is that tension builds up when the plates are grinding past each other. Bits of the rock get trapped on each other, and the tension builds. And essentially, when that tension is released, that is the earthquake. That is the energy that is released. Now, there is something I want you to do, and bear with me. So what I'd like you to do is put your hands next to each other. And I just want you to rub them past each other like that. And what you should feel is probably some heat. Now, that's friction, okay, that's creating the heat. Now, you've got lovely smooth hands, hopefully smoother than mine, but imagine 2 enormous, enormous pieces of rock moving past each other. They don't have smooth edges, so they get caught, they get stuck. And actually, essentially, because they want to keep on moving due to the convection currents, eventually that energy is released in the form of an earthquake. Very cool. So, if you want to pause the video, take some notes. That is how a conservative plate margin works. And as I say, really important to remember that only earthquakes occur on conservative margins. Okay, so we've had a look at a conservative plate margin. So what I wanted us to do now is kind of apply what it is that we've just learned and see if we can complete this gap fill. So first of all, have a look at the photograph that is on the left-hand side of your screen. Now, that shows one of the most famous conservative plate margins in the world, the San Andreas Fault. And if you have a look, you can see that there is a dark line down the middle of that picture. And that shows the 2 different tectonic plates. And one is moving in one direction and one is moving in another. So all I want you to do, please, is to write out the following sentences and then to use the words in bold to fill in the gaps. So the photograph shows the San Andreas Fault line, a something plate boundary. The 2 tectonic plates are moving each other. This causes to build up, and when it is, this causes an earthquake. So pause the video now, write the sentences out, add those keywords into the gaps, and you have got a perfect explanation of what is happening on a conservative plate margin. Okay, so a fairly simple task, but let's go through the right answers. Give yourself a huge tick if you got one of them correct, and perhaps highlight those key terms. So the photograph shows the San Andreas Fault line, a conservative plate boundary. The 2 tectonic plates are moving past each other. This causes tension to build up, and when it is released, this causes an earthquake. So give yourself a tick for each of those that you got correct. And then let's move on to the main task for today's session. Okay, so here is the main task for today's session. And essentially what you're going to do is apply the knowledge that you learned earlier about destructive plate margins. So it says, using the image below, explain why earthquakes occur on destructive plate margins. Now, to help you out, what I've done is given you some key terms, and I've given them to you in the correct order that you may want to use them in. So we've got earthquake, towards each other, continental plate, oceanic, subduction, and pressure. Now, what I would do if I was you is to go back to the diagram that you created earlier and to use that to help you structure that answer. Now, remember, it says using the image below. So what you might want to do is say, the image shows a destructive plate margin, and then crack on. But remember as well, we've got to mention the fact it causes earthquakes. That's what the important part is. There's no mention in this question of how it causes volcanoes, but it could do in a different context. So pause the video now, crack on with answering the question, and then we'll go through the answers. Okay, so did you get? Now, it was just a 4-mark question, but there is actually a lot of geography in this answer. And as you can see, I've used all of those key terms that I put on the list in the same order that they were on the list. So the image shows earthquakes occur on destructive plate boundaries. Now, if you said destructive plate margins, that is also fine. Remember, those two terms are completely interchangeable. The two plates are moving towards each other. The denser oceanic plate is subducted below the continental plate. This exerts pressure on the crust, and when that pressure is released, it results in an earthquake. Now you can see where I put the little ones in brackets. That shows where I would have got a mark for each part of my answer. So what I'd like you to do is to look at your answer, give it a mark for each of those sentences that you've used. Again, make sure that you've got the correct sequence, and then highlight those key terms that you can see in that answer. Right, that brings us to the end of today's session. You have done so well today. I am really proud of you. So just to recap what it is that we've learned, last session, obviously, we looked at constructive plate margins. Today, we've looked at destructive and conservative plate margins. So on a destructive plate margin, you have your oceanic and your continental plate moving towards one another, and the oceanic plate is subducted below the continental plate. This can create, remember, two hazards, earthquakes and volcanoes. Whereas then we looked at our conservative plate margin, and actually on a conservative margin, the two plates are moving past each other, either in opposite directions or at different speeds. And the only tectonic hazard that occurs there would be an earthquake. Now, it's really good practice to go back through the notes that you made today, highlight 3 things that you think are really important so that they stick in your memory, and then hopefully I will see you for our next session.